Hello, today we're going to look at the last lesson that we're going to do for chapter 10. This last section, 10.5, is all about Pythagorean theorem. You may have learned about Pythagorean theorem before. A squared plus b squared equals c squared. Pythagorean theorem is essentially a formula that we use for right triangles only to find the length of a missing side. When you take a look at a right triangle, every right triangle has, of course, one right angle. In your right triangle, the two sides that form the right angle are called the legs. In Pythagorean theorem, the legs are notated as A and B. The third side of the triangle, which is always directly across from the right angle, it's also the longest side, is called the hypotenuse. And that's side C. When you look at Pythagorean theorem, a squared plus b squared equals c squared means that if you square the lengths of the two legs and add them together, that'll always be the same number as squaring the length of the hypotenuse. It doesn't matter which leg you call A and which leg you call B in Pythagorean theorem, but it is important that you always use the longest side across from the right angle as the hypotenuse C. So let's use Pythagorean theorem to find the length of a missing side of a right triangle. In the next set of examples, it says find the length of each missing side, round to the nearest tenth. So in question number 1, when we take a look at this, first of all, we do have a right triangle. We're missing the hypotenuse, side C. So when I plug into Pythagorean theorem, first I take the two legs. So here the legs are 30 and 40. I square each leg. So 30 squared plus 40 squared equals, we're looking for the hypotenuse, so c squared. Once you plug into Pythagorean theorem, figure out what 30 squared is, what 40 squared is. So that's 900 and 1600 equals c squared. Then you can solve for c. So combine like terms. 2500 equals c squared. And since we want plain old c, not c squared, remember the opposite of squaring is to square root. When we square root the left side, the square root of 2500 is 50. On the right side, squaring and square rooting cancel each other out, and we just get c. So the hypotenuse of this right triangle is 50 units long. Question number 2, again we have a right triangle. This time we're missing one of the legs. So when we fill in Pythagorean theorem, let's say a squared plus the other leg, which is 15 squared, equals our hypotenuse, 39 squared. Again, simplify each number. So this becomes a squared plus 225 equals 1521. Solve for a squared. So we're going to subtract that 225 from both sides. So that a squared equals 1296. To get plain old a, we square root both sides and find that a is 36. In question number 3, we're back to looking for the hypotenuse of this right triangle. Remember, it doesn't matter which leg is A and which is B. So let's do the square root of 15 squared plus the other leg 4 squared equals our hypotenuse, c squared. The square root of 15 squared is 15. 4 squared is 16. Combine like terms. So 31 equals c squared. And then square root both sides. to get plain old C. So C is the square root of 31, or when you put that into your calculator, that's about 5.6. More often than not, when we use Pythagorean theorem, we'll find that the lengths of the sides of the triangle are decimals. That's absolutely fine. It does not mean that your answer is incorrect. And the last example over here, question number 4, we have the hypotenuse. We have one leg. We're missing the other leg. So when we plug into Pythagorean theorem, 5 squared plus b squared equals the square root of 89 squared. 5 squared is 25. The square root of 89 squared is 89. And now we can solve for b. So we subtract 25 from both sides. So b squared equals 64. And when we square root both sides to get b alone, b should be 8. Okay, when you flip over to the back of your notes, Pythagorean theorem is typically used to find the length of a side of a right triangle, just like we did on the front. But it also has a second use. The converse to Pythagorean theorem, which just means backwards essentially, says that if I am given any triangle and I plug the sides into Pythagorean theorem, so if I know all 3 side lengths and I can plug them into a squared plus b squared equals c squared, and I get a true statement, if a squared plus b squared does actually equal c squared, then I can say that triangle has to be a right triangle. If a squared plus b squared does not equal c squared, then I don't have a right triangle. So I can figure out whether or not a triangle is right using the 3 lengths of the sides. So we'll do exactly that in question 6 and 7. When you look at the lengths of the 3 sides that are given, remember that the hypotenuse has to be the longest side. So the square root of 10 is about 3.1. The square root of 12 is about 3.5. And then the last number we're given, 5, is definitely the biggest. So when I plug into Pythagorean theorem, 10, the square root of 10, and the square root of 12 would have to be the legs. 5, the biggest side, has to be c. So I plug in all 3 values, and I'm checking to see, is the square root of 10 squared plus the square root of 12 squared equal to 5 squared? Well, the square root of 10 squared is 10. The square root of 12 squared is 12. 5 squared is 25. On the left side, if I combine like terms, 10 and 12 is 22. 22 does not equal 25. So my final answer here is no, these 3 lengths cannot form a right triangle. Let's do the same idea for question number 6. The longest side, the biggest number, has to be the c. So I plug all 3 values into Pythagorean theorem. Here we have 7 squared plus 24 squared. And we want to know, does that equal 25 squared? 7 squared is 49. 24 squared is 576. 25 squared is 625. And when we combine like terms on the left, we end up with 625 equals 625. So this makes a true statement. That means that yes, these 3 lengths can be the sides of a right triangle. And the last part of today's lesson is about Pythagorean triples. A Pythagorean triple is just a set of numbers that are the sides of a right triangle, but they are also whole numbers. So triple, of course, means three things. Pythagorean relates to right triangles. So a Pythagorean triple are three whole numbers that work in Pythagorean theorem. So we have to find two constraints. Number one, are all the numbers whole numbers? So no fractions, no decimals. And then number two, do those sides actually form a right triangle? Do they work in a squared plus b squared equals c squared? When you take a look at question number 7, notice we have the same numbers from question number 6. So I already know that 7 squared plus 24 squared equals 25 squared. I know that these numbers fit in Pythagorean theorem. The second requirement is that they are all whole numbers. So here, these sides, 7, 24, and 25, have no fractions, no decimals, nothing crazy. They are whole numbers. So yes, 7, 24, 25 is a Pythagorean triple. When you take a look at question number 8, the square root of 4 is 2, but the square root of 6 is about 2.5, I'm guessing. So when I take a look at just these three sides, square root 4, square root 6, square root 10, I automatically know that these numbers do not form a Pythagorean triple. I don't have to do any work because these are not whole numbers. They have fractions or decimals, so this last one is a no. Please make sure you complete the homework tonight, which is attached to the notes. Make sure you show your work for full credit. Have a great day.